Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is software estimations using function points. Our guest speaker today is Mr. Allan Nayak, Development Manager at Cross Country Infotech. He has more than 12 years of experience in IT industry, primarily in design, development and implementation of Java and J2EE applications, function point estimations and project management. Prior to Cross Country, Mr. Nayak was working with Capgemini, former Canbay, for Morgan Stanley's fixed income division. After doing engineering from University of Pune, he completed diploma in advanced computing from CDAC Bangalore. Anand is also a PMI certified project management professional, IFPUG certified function point specialist, Salesforce certified Force.com developer, Sun certified web component developer, and Sun certified Java programmer. So without further delay, I introduce you all to our guest speaker, Mr. Allan Nayak. Over to you, Mr. Nayak.
Good afternoon, everyone. Thank you for attending this seminar. My name is Anand, and I'll be presenting on software estimations using function points. Let's look at some of the standard problems that we face with software sizing. And here is an interesting example. We'll look at two project managers and just see the way they're speaking. Okay. Here is project manager A and project manager B. Project manager A is saying that this is a really huge project, and based on the expert judgment, and I'll emphasize on the expert judgment part of it, it needs a lot of effort. Whereas project manager B is saying this project is estimated at 100 function points, and with our past productivity of 12 hours per function point, it needs 12,000 hours of effort. As you would see, project manager B looks smarter as compared to project manager A, because project manager is talking in more subjective terms. Lot of effort, expert judgment, and huge project depend on how you perceive it. For me, a definition of huge project may be different as compared to your definition of a huge project. For me, a lot of effort means maybe 10 hours of effort. For you, it may mean 100 hours of effort. So you see that difference, right? Now we'll see it's not the only problem that you will face in software sizing. It's not just about talking and comparing two things, but there are a lot of other things which are associated with it. Let's look at some of them. Normalization factor for software comparison. Now if you see, if you need to compare one application with other application, there is no normalization factor. Now previously there used to be lines of code, but lines of code has its own drawbacks because there is no universally accepted definition of lines of code. People who write smarter code are punished because then number of lines of code are less, and people who write lengthy code, then the number of lines of code is more. So, and lines of code you can only know after the fact, that is after the project is done or project is completed, after your programming is completed. You must have always heard, whenever someone asks you to estimate certain thing, you'll say, okay, if we do it in Java, it will take 100 hours. If I do it in .NET, it will take 120 hours. So there is always, you see that influence of technology when you do estimations. Sometimes you must have also heard that person A, if he's an expert person and I would like him to do estimation. So there is always dependency on the domain expert. As in the example we have seen, it's difficult to quantify what is big, what is small. It's difficult to measure productivity also. How do you measure productivity is difficult. There has to be some common criteria based on which you can measure productivity. You cannot just say in a subjective term that okay, my developers are more productive than your developers. But what does it mean? Then you say okay, this was a huge project and they have completed in 100% hours. It has no meaning for me because you are talking in subjective terms. It's a huge project, has no meaning to it. So to bring meaning to things like this, to calculate different metrics, to compare two products, and definitely to calculate efforts based on the requirements is where function points are used. Before we go ahead, I want to clarify one thing is function point is for sizing software and it is helpful in calculating the effort. So it is not a tool which is primarily used for calculating, just for calculating effort, I would say. So having said that, let's start looking at more into what is function point and the details of it. So what are function points? Function point, they measure software size by quantifying the functionality provided to the user. So it is from end user's perspective. It is sizing of the requirement. It is independent of the technology. It's a method of quantifying the size and complexity of the system in terms of functions that the system delivers to the user. So, function points, if you see in scientific applications where there are a lot of algorithms calculations involved, you don't use function points. Embedded systems will not use function points generally. It is independent of the programming language, development methodology, or capability of the project team to develop the application. So it is independent of all these things. International function point users group has provided guidelines to calculate function point, and they have documents which are published, which is called as Counting Practice Manual. So it's a non-profit organization which owns function points. The current version of Counting Practice Manual in circulation is 4.3. So it gives you a lot of details, lot of guidelines as to how you should be calculating a function point. A lot of nitty-gritties are involved in it. So I would suggest if you are really interested in pursuing further into function points, you can be a member of IFPUG and you can download Counting Practice Manual, go through it, it will give you a lot of information on function points. Let's look at why IFPUG says we should use function points. You cannot manage internally what you do not measure. How do you measure anything that, how do you manage anything that you cannot measure? It's really difficult because, I want to know how many defects, I want to know what is, how many defects are my application producing, and I'll say my application produced 10 defects, but maybe it was a 10-hour project, right? And then it looks different. If I say, my application produced 10 defects and it was 1,000-hour project, yeah, your developers are better than the previous project, right? So unless you know based on which you are talking or the context in which you are talking, it's difficult. So unless you measure, you cannot manage it. You cannot say, okay, because there are 10 defects here, I need to work on my developer, give them some more training. You need to have put it in some kind of context where function point will help you. I hate to talk, but approximately 40% of all the projects fail due to lack of management control, and in software you all know about this. I don't think I need to talk more about this. It's a tool to communicate with your customer. Now, IFPUG is a standard tool which has been accepted by the industry, which has been accepted by various organizations and government. So when you talk in terms of the cost, the effort, the defects, we talk in terms of function point, and that gives you a good basis to communicate it with your customer. Your competitors may already have insights, and then you also, when you come up with different metrics, for example, how many defects are produced per function point, what is the effort per function point, what is the rate of delivery. So these kind of metrics will help you improve your processes. Unless you know where to improve, you won't be able to improve it. Otherwise, you'll concentrate your effort on some wrong things. So let's look at briefly the history of function point. So the credit of function point goes to Allan Albrecht of IBM, who has published this paper on function point. So he started a function point. So he is, I would say, the father of function point methodology. It was in 1979 he published that. In 1984, first formal function point guidelines were published. IFPUG was constituted and the elected board of directors in 1986. Function point as an asset manual was published in 1990. CPM is Counting Practice Manual, release 4.0 was published in 1994. Release 4.1 was in 1999, and in 2004 it's release 4.2, and in 2010 they have published the latest release, which is release 4.3. So this is briefly about what function point is and the history of function point. Now we'll start to go into more details of function point and how you calculate function points. So the first thing that you do is gather available documentation. So documentation that you will need to calculate function point. And there's a brief slide in the session where I'll show you what kind of documentation is required, which is more at a broad level. But more the documentation, more the accurate documentation you have, better it is to calculate function points. The available documentation will involve your SRS, your use cases, your data dictionary, your database design, and there are a lot of your subject matter expert, your screens, your entity relationship diagrams. Determine counting scope. We are going to look into more of each of these items, but let's just look at on a broad level what is the process. Determine counting scope, boundary, and identify function user requirements. Identify major and major data functions, major transaction functions, calculate functional size, document and report. So on a broad level, these are all the things which you require to calculate function points. Another important thing is when you should calculate function points. So you already know SDLC cycle. We have requirements, design, development, testing, deployment, and maintenance. These are the phases through which an application would generally go through. So you calculate it at the end of your requirements phase, at the end of design, and for that matter, anytime the requirement changes, you need to go back and recalculate your function points. After the deployment, once the application is deployed, you finally calculate the function point, and during maintenance, you keep on updating the application function point count. We are going to see the types of function point counts, and there are different function point types of function points which we'll see sooner. So these are some of the things. The post requirement or requirement change and post design and post deployment. The inputs is like your project charter, your change request, your requirement documents, your design documents, your subject matter expert. And the output would be updated function points, updated effort estimate, and this may result into updating your project plan, because once you update your effort estimate, it may have impact on your project schedule. Maintenance, you will take updates from the previous stages. You will have subject matter expert as your input, and the change request, that is nothing but the requirements, the change request requirements, using which you will calculate function points, update your effort estimate, and if required, your project plan. Details of how you calculate. Now, we are looking at a broad level. Let's look into more details of how you calculate function points. So you understand requirement, define system boundary, identify elementary process. you identify ILFs and EIFs. Now you'll start to see these abbreviations or short forms of different things. I'm going to explain you what is ILF and EIF. Next is ILF and EIF are data functions. So the previous slide you must have seen data calculate data functions. You determine their complexity. You determine transaction functions which are EI, EO, and EQ, and we'll see what this means. Then you determine their complexity. You calculate UFP, which is unadjusted function points for from the table. So there are tables which are provided using which you can calculate unadjusted function points. You calculate total unadjusted function points. You use 14 General System Characteris. Determine TDI, that is total degree of influence, using 14 General System Characteristics, and then you calculate the final adjusted FP. Let me also mention here that function point is an ISO standard, and the General System Characteristic and degree of influence is outside ISO standard. So generally nowadays people do not calculate General System Characteristics, and they just use it as one and just purely work on the unadjusted function points. There is another process which one of the things which function points will not cover is your technical requirements and your quality related requirements, and IFPUG has started a separate process called a SNAP to cater to these kind of requirements, which we are not going to talk in this session. Okay, so these are different definitions. We are going to go into more details of it. So I'll just wait here for a minute for you to just go over it, and then I'll move to the next slide. Okay. So let's look at the first thing, which is to determine scope and boundary. So the scope defines subset of software being sized by identifying the functions that will be included in functional size measurement. So you identify what is that user is requesting. There are three types of function points. One is development function point, enhancement function point, and application function point. So if you look at this diagram, project X development function point will initialize application function point count. Project Y, which is an enhancement project based on project X, will update that application function point count. Now there is a difference between these three counts, and as we go ahead in our session, I'll tell you more about it. But what I would like to mention is when you calculate development project function points purely, it includes something called as conversion function points. Similarly, when you calculate enhancement function points, it includes something called as conversion function points. Although when you calculate application function points, it does not include conversion function points. Now, what are conversion function points? We are going to see it later. So boundary is the border between the application being measured and either the external application or user domain. Now, there are definitions of what is user. So user is a human being or anything that interacts with software at any time. The boundary acts as a membrane through which data is processed and passes in and out of the application. It is very important to determine what is application boundary, what is inside the application and what is outside the application, without which you will end up calculating incorrect function points. So this is the first and a very important step in function point, counting function points. So let's look at this example. If you see there are two applications. One is e-commerce application and one is payment gateway. And user 1 is accessing order data from e-commerce application, whereas e-commerce application is communicating with payment gateway to send some payment information. Now, if you are going to calculate function point for e-commerce application, you need to determine the boundary. So order data is something which e-commerce application maintains, whereas payment data is something which payment gateway is maintaining. Which means that only order data is part of e-commerce application, and that's why the application boundary which is shown only includes order data and not payment data. Payment gateway is a separate application which need not be considered because we are calculating function points for e-commerce application. Let's look at what are the data functions. So here is an example where user 1 sends a request to update profile. User 1 is sending request to application A, and profile is something which is maintained in the database through application A. And then there is application B. So when the user is updating the profile, application A will use user's database to authenticate the user. Application B is an admin application which admin maintains all the users. So now the application under consideration for us to calculate function points is application A. So internal logical file is a user recognizable group of logically related data or control information maintained inside an application being measured. Now when you say maintain means add, update or delete. So application A is actually adding, updating, deleting profile information. So for application A, profile, user profile is an internal logical file, whereas it is just accessing user's database. It is not maintaining it. It is not adding, modifying or deleting anything in the user's database. That is why it is external interface file for application A. An external interface file is a user recognizable group of logically related data or control information referenced by the application being measured, and which is maintained by some other application. So in this case, application B is actually maintaining user database and not application A. Now let's say tomorrow if you wanted to calculate function points for application B, user's database would be ILF for application B. That is the internal logical file which application B maintains. Now also I would like to emphasize here on the word logical, because generally people tend to confuse it with the actual database tables. It could be actual database tables, but it is how the end user sees it. And in the database, from the technology perspective, you have implemented it in a different way. Maybe user profile is actually 10 tables inside your database, but for user it represents one logical group of data. So that is what you need to take into account when you are calculating it. So the next is to calculate a data function. How we count function points for data function. So if you remember, I'll just go back. The first thing that we have seen is to identify scope and boundary. We have seen what are data functions, what are internal logical files, what are external logical files. The next step is to actually count function points for data functions. After this, we'll also see how to count data functions for transaction functions, and then combine them together to come up with a final function points. So this is third step in the function point counting, is to count function points for data functions. So first is you need to identify data functions. You calculate something called as data element type DETs. We'll see that. I know there are a lot of different terms that are used here which you may not be used to, but it's just a matter of getting used to it. And it is, I would definitely say that function points are simple to use, but obviously you need to understand it before you start using it. Calculate record element types, which are RETs. RETs are slightly difficult to calculate, and in the sense that because there is always a confusion on whether or not to treat something as a RET or not. So there are some guidelines on that as well. Calculate complexity of the data function, and then calculate function points. So for data functions and for transaction functions, you need to calculate the complexity first, and then there is a table which will help you based on that complexity calculate the function points. So the first step in data functions is to identify data functions. How do you identify data functions? So identify all the logically related and user recognizable data and control information within the counting scope. So yeah, it's definitely a complex process, and it will take some time for you to understand. But you need to just hang in there because once you understand it, I think you'll be able to count function point separately. So the terminologies are difficult in the first place to understand, but as you use it, you will know more about it. Exclude entities that are not maintained by any application. So once you calculate entities, you see that there are some of the entities which are really not maintained by any. By maintain, again, I mean add, modify, delete. Group related entities that are entity dependent. So there could be two entities which could be user and user address information. So you may want to combine them together because user address cannot just exist on its own because and it needs to be related back to the user information. So this actually represents one logical group of data. Exclude entities that are referred to as code data. Now code data is something like a static data or a substitution data or valid values data or range of values. This kind of data is referred to as static data, and you don't need to calculate anything related to code data. So in your function point, do not include code data, which is more like a static data. Let's say you are storing some properties, or then you have list of countries in your database which are static. So you don't need to take these into account. Then if there are any attributes which user does not require and there is an entity you just neglect it, remove associative entities that contain additional attributes that are not required by the user. Now there are two concepts. One is associative entities and one is attributive entities. Associative entities is, for example, let's say you have a logical group called as jobs, and then you have another logical group called as applications. So there is a job which is posted and the applications that are received, and there is an association which is made in job and application. So it is a logical group which says this job and this is the applicant. So this is an associative entity. If it does not contain any additional attributes so that it can be identified as a separate logical file, do not count it. Okay. Next is to calculate data element types. So this is again a simple example where user one is updating a profile using application A, and then in the profile there are 4 attributes that you see: name, address, and email and phone number. So user is trying to update the profile. Basically, he's trying to update this information. So data element type is a user recognizable. By user recognizable, it means that the user and the developers have agreed upon certain things. Non-repeated. So if the attribute is getting repeated multiple times, you count it only once. That is either maintained or retrieved. Maintain is again add, modify, delete. Retrieve is like a select query. For execution of an elementary process. Elementary process in this case is update profile. We'll see more about what elementary process is. Count only those DETs which are used by the application. So don't count any other DETs. Calculate DETs that are generated within the application boundary and maintain in ILS. So when you are calculating DETs for data functions, you also calculate not only the DETs which user has sent, but also the DETs which maybe are internally generated. So for example, you are generating let's say some token for this user internally and storing it in the profile ILF. So that will be counted as a DET on that ILF. DET is data element type, ILF is your internal logical file. So if you look at this example, there are 4 data element types which you will calculate on this ILF. Okay, so just to remind where we have reached is we are still in calculating data functions. We have seen how to identify application boundary, how to determine scope, different types of function point counts. We are in the data functions. We have seen different types of data functions, how to identify them. To calculate complexity, we need to know DETs, which are data element types, and now we need to know RETs, which are record element types, is what we are going to see now. Okay. Okay, record element type is a user recognizable subgroup of data type within a data function. So the guideline is to count one RET for each data function by default. Count one additional RET for associative entity with non-key attributes, attributive entity in relationship other than one-to-one, and subtype entity. We'll see what it is. So if you look at the first example, which is employee and employee benefits, it's an attributive entity. Attributive entity is an entity which tells more about employee or more about the primary entity. So in this case, employee benefit is giving you more information of primary entity, which in this case is employee. There is another example, which is you have 2 types of employees, which is permanent employee and contract employee, which refers to subtype of it. So here you will count it as 2. So in both the examples, you see there are 2 RETs which are calculated for employee benefits and permanent and contract employees. I see some of the questions coming through. I'll try to answer them at the end of the session. Okay, so now once you have calculated DETs and RETs, you actually calculate data function complexity and function points. And this is a table. If you see, the columns are for DETs and the rows for RETs. And suppose the example which is written there is application contains one ILF with 51 DETs and 4 RETs. So if you look in the table, 51 DETs and 4 RETs, it is in the 3rd column, 2nd row, which tells you that it's high complexity. If you look at the table below for ILF, high complexity is 15 function points. Similarly, there is an EIF with 1 DET and 7 RETs, which is of average complexity. So it is 7. So 15 plus 7 is 22. So total 22 function points are data function points are what we have calculated here. Okay, so next is we have completed calculating data functions. Now next is to calculate transaction functions. And once you calculate data functions and once you calculate transaction functions, you are almost there to calculate the final function points. So let's look at the transaction functions and what transaction functions mean. So first is external input, which is an elementary process that processes data or control information sent from outside the boundary to inside, and the primary intent is to maintain one or more ILFs. The primary intent is the intent which is first in importance. We'll see what elementary process means. We'll look at the example now. So we have application A and there is an ILF which is maintained by application A. We have application B. There is a typo there, it should be EIF. So for application A, we are going to, A is going to be our primary application. So for application A, the data is in application B is EIF external interface file. So let's say, for example, user is initiating action, which is add user info action from the browser. User has initiated that action which hits your application. Or then there is some data feed which is coming from some other application which your application is accepting. So these two are examples of what is called as EI, which is external input, where data is sent from outside to inside the boundary. Next is external query, which is an elementary process where data or control information is sent outside the boundary, and the primary intent is to display data to the user. So let's say display sales report in the browser is an external query. There could be something like you are sending feeds to other applications, which could be external query. The third transaction function, which is external output, is an elementary process where data or control information is sent from inside to outside, and which involves processing logic other than or in addition to just retrieving the data. The primary intent is again to present data to the user. Now the difference between external query and external output is external output performs calculations, or it creates derived data, or it may maintain one or more ILFs. The primary intent is the same, but the way the processing is done will differ. One elementary process from one EQ from other EO, and the difference is the calculation and derived data part of it. So let's say report with additional calculations. So let's say you have retrieved some data from your database, you do some more calculations on it before you display it to the user. So that is your external output. Or you are requesting to display report in the browser. By doing so, you are maintaining one ILF saying that some user has accessed this report. That's external output. Okay. The next is how we calculate function points for transaction function and the steps. Like we have seen for data functions, we will see it for transaction functions. First is you need to identify elementary process. Then you determine unique elementary process. There may be multiple elementary process and some of them may be same. Classify each elementary process as EI, or EQ, which we have just seen. Calculate DETS and FPRs, data element types, and 5 types reference. 5 types reference are nothing but EIF or ILF. Calculate the complexity and calculate the transaction function points. So these are all the steps. We'll see each of them one by one. Let's take an example where again it's add the user details. I don't know why I like this example, but it seems like a basic example everyone can understand. So now add user details, actually, let's say it's like a wizard. And there are 3 things. One is add basic info, add educational details, and add previous employment details. So add user details is an elementary process. Now we'll see why it is an elementary process. Because it is, now these are different characteristics of elementary process. It is meaningful to the user since it is satisfying the functional user requirement, which is to add user details. It constitutes complete transaction, including adding basic user details, educational details, and previous employment details. Now let's say you just say that, okay, add educational details. It does not have any meaning unless it is associated with add basic info. So add basic info along with additional details and previous employment details constitutes complete transaction. It is self-contained. There are no pre-processing and post-processing that is required. And a point where the processing complete, which is after, let's say, user clicks on save button after adding all this data, the functional user requirement is satisfied, and then there is nothing more to be done. So these are all the 4 characteristics. It has to be meaningful to the user, it should constitute complete transaction, it should be self-contained, and should leave the business state of the application in a consistent state. it's a unique process. So if you see, if there are multiple processes which are doing the same thing, add user detail, you count only one. But if there are no other processes that have same processing logic and same number of DETs and FTRs, you count them as unique. So the test case to know whether the other process is unique is to see whether it is having same processing logic or whether the number of DETs are same and whether the number of FTRs are same. If they are same, they consider them as same elementary processes. It is an external input, so you are identifying now what is it. It's an external input because the data is sent from outside the boundary to inside, and it is maintaining one or more ILFs. So considering, let's say, the number of DETs to be 6, and since it's updating one ILF which is equal to 1 FTR, the function point count from the function point table would be 3. Now this is an important table as to how do you classify function points, and there's various processing logic is involved. So based on the processing logic, how do you calculate it is what is given in this table. C stands for function type can perform this type of processing logic, but it's not mandatory. M is it is mandatory that function type performs this kind of processing logic. M star it is mandatory that the function type performs at least one of M stars. So if you look at EI, important thing is the data or control information is entering the boundary of the application. At least one or more ILF is maintained. For EO, you see the mandatory thing is information is prepared and sent outside the boundary of the application. And one of the other three, which are mathematical calculations performed, one or more ILFs updated, and derived data is created. One of them needs to be satisfied for it to be calculated as external output. Okay. How we calculate now? Now this is the transaction function. We have seen calculating DETs in data functions. We'll see how you calculate it in the transaction function. So calculate all user recognizable data element types that are sent from outside the boundary to inside for EI, and for EQ and EO calculate all the DETs that are sent from inside the application to outside. We'll also see an example of this. Count only those DETs which are used by the application, do not count DETs that do not cross the boundary. So for transaction function and in data function, this is the major difference, that you only calculate DETs which are crossing the boundary, which is either entering the boundary or exiting the boundary. Calculate number of FTRs or ILFs and EIs that the elementary process uses. And one additional DET you need to calculate for ability to initiate action. For example, you click on a save button. That's an ability to initiate action. So you calculate one DET for it, and for receiving response messages that your user profile says successfully is a message that you are sending back. To calculate one more DET for it. So here is an example where it's asking for first name, last name, phone, email address, profession, specialty, some promotional code, and get started. So there are 9 DETs, which are first name, last name, phone number, cell phone number, then not cell phone number, but a phone type, email address, profession, your specialty, promotional code, and get started is also getting calculated. And because there are no response messages, I have not calculated one more DET. One more thing to understand here is, first name and last name, the way it is treated can be sometimes calculated as one DET, and it depends on how the application treats it. Are they treated separately? Let's say, for example, there is a sorting mechanism where these were getting sorted separately, or at some places first name is used and last name is not used. So the way you look at it will differ, and where the functional user requirements will dictate whether you want to calculate them as one DET or 2 DETs. So here is the table for calculating transaction functions. Let's say, for example, if an application contains one EI with 6 DETs and 2 FTRs. So if you look at in the external input table, 6 DETs and 2 FTRs is of average complexity. And you look in the table for EI, average complexity is 4 function points. And there is an EO with 7 DETs and 4 FTRs. This is a high complexity EO, which are nothing but 7 function points. So the total transaction function points are 11. So we have calculated now the function points, and the next step is to sum the data function points and transaction function points to arrive at unadjusted function points. So we have seen how to determine scope, how to determine application boundary, how to calculate data function points, how to calculate transaction function points, and now we have arrived at a place where we can calculate unadjusted function points. Okay. Next is enhancement. I was just browsing through the questions. I'm going to take it up at the end, but I was just browsing through it for a moment. Enhancement and conversion function point. Now, once you calculate the development function point count, there are two more things. One is enhancement function point count. Now, what you calculate in enhancement, there are 3 types of enhancement that you do, or maintenance activities that you do. One is called as adaptive maintenance, one is corrective maintenance, and the third one is perfective maintenance. Now, adaptive maintenance is like, for example, a change request which the user has requested to make some updates to their application. Corrective maintenance is more like bug fixes. Perfective maintenance is for tuning the performance of your application. As far as function points are concerned, it only caters to adaptive maintenance part of it. So the enhancement project, functional size measures project modifications to install applications that add, change, or delete user functions. To calculate enhancement function points, identify and evaluate added functionality, identify and evaluate change functionality by determining the complexity of the points prior to change and after the change, identify and evaluate deleted functionality. So that's the difference. Deleted is something also you calculate. So that's about the enhancement functionality. We'll see what is different formulas for calculating this, but you add up the added functions, the change functions, and the deleted functions to calculate enhancement function points. Now the conversion of functionality needs to be considered for development and enhancement function. While calculating development and enhancement function points, you only consider conversion functionality, not for the application. Now conversion functionality, for example, there is a user requirement to convert data from previous application or to migrate it from previous application to next application. So that is what it means by conversion functionality. And where you will be writing some code for that conversion, and you are not using any pre-existing tools to convert that data from previous application to the new application. It executes again existing data in a separate application and populates one or more logical files in order to fulfill specific user requirements. So you are migrating your old legacy application to a new application, and you are going to, and there is a specific user requirement to use that, have that data in place. So that's where your conversion function points will be calculated. Conversion function points will involve your ILS. Conversion function points will involve your transaction functions as well. So till this point, what we have seen is what is covered as in the ISO standard. The next part of it is value adjustment factors, which is not now part of a ISO standard. And the practice that we follow is not to calculate value adjustment factors, because then the subjectivity starts to creep in. and you can always adjust your productivity factor to calculate the effort in case you require it. But we'll just briefly go over value adjustment factors. Value adjustment factor is based on 14 general system characteristics that measure general functionality of the application being measured, and each characteristic has guideline to determine the degree of influence that characteristic has on the application. And it is measured from scale 0 to 5, which is no influence to strong influence. They are summarized in value adjustment factor. Value adjustment factor adjusts the functional size by plus or minus 35%. So your unadjusted function point will get adjusted by plus or minus 35% max. So these are different general system characteristics, and these are the values that they can have: 0, 1, 2, 3, 4, 5, starting with not present to strong influence. We'll see one of them. We'll see each of them. Then you calculate total degree of influence, which is nothing but sum of the values for all these 14 general system characteristics. So let's look at them. Data communication, distributed data processing performance, heavily used configuration, transaction rate, online data entry, and end user efficiency. Data communication is how many communication facilities are available. Distributed is for distributed data processing. If there are any specific performance requirements that are stated by the user, it will come into performance general system characteristics. Transaction rate is how frequently the transactions are happening. End user efficiency is the application designed for end user. Is it going to be designed for end user efficiency? Is there a requirement for it to be designed to be efficient for the end user? These are rest of them. I'm not going to get into much details of value or general system characteristics. There is a lot of documentation which is available in counting practice manual, and there is a lot of data which is available which gives you more details of each of them with examples. So let's look at one of the simple example. Now this is how you will calculate it. So you have ILF and EIF, and there is one transaction function, and then you have calculated the number of functions, the complexity of it, and you calculate total function points. Right now, the last row that you see is, say, with 8 hours per function point, it is coming to 1472 hours. Now this is something which is different, right? We've been calculating function points for so long. Now the important thing is now to come up with some data that we can use. And one of the important things with function points is you can have different kinds of metrics. So now once you have calculated function point, which is irrespective of the technology, you can say that, okay, my productivity for developing this project in Java is 8 hours per function point, which you can use industry standard data, which is available for each technology, how many function points, or you can have your organization specific data. So you say, in my organization, my developers are more productive, so I will use 6 hours per function point. Now, how do you determine that? Now, it's not a simple thing. You need to calculate. You need to have your data repository neatly maintained. You need to have function points and the actual effort a project has taken over the period of time, and that's when you will know that how much is my productivity. There is another interesting thing about function point is there are a lot of tables and a lot of analysis which have been done on function point, and data has been gathered. It can also tell you how many defects your application can produce. It will also tell you the number of test cases that your application will have. It's based on the data which is collected over the period of time by different agencies, and it is available from these agencies. And it's once you calculate that, there are different other metrics which you can calculate. For example, hours per function point we have seen, there could be overall productivity, there could be rate of delivery, which is calculated by dividing number of function points by the elapsed calendar time. In the quality area, you can say functional requirement size, then completeness or a rate of change, which is more like a volatility or scope creep related. Defect density is another important matrix. It's by dividing the total number of defects by the total number of function points. You can also say what is my cost per function point, what is my portfolio asset value, repair cost value. So basically, because you have calculated function point, which is technology neutral, and where I can compare various projects, I can calculate this different matrix, because now it is giving me that normalization factor which I require. These are some of the formulas. I'll just leave this slide open for some time. I'll start answering some of the questions that have been raised that I see here. Okay, the first question is, are there any evidences of this method being used in telecom and networking projects? I myself have not worked on any telecom and networking project, but I'm for sure it is used must have been used in some telecom and networking project. Now remember one thing, as I said in the beginning of this presentation, is nothing about telecom or networking project or specific to any specific domain. It actually gives you a facility by which you can size the end user requirement. So even if it is a SaaS application, I think there is one more question related to SaaS. You can still calculate, because ultimately it's going to be the end user requirement which your SaaS application is going to satisfy. What will probably vary is your productivity factor. So you will say, let's say I want to develop same application on Salesforce, then probably I'll not use 8 hours per function point, but I'll maybe use 1 hour or 2 hours per function point, because a lot of things are already present there. It's just more of a configuration, but the function point will still remain the same. So I'll say 50 is my function point size, and I want to develop it on Salesforce. It will take me 100 hours. If I want to develop it in Java, I'll take some different number of hours. Okay, are these tables for function point universal, or are they application specific? These are universal tables which are provided in accounting practice manual by IFPUG. Can you share any links with detailed examples for this? For I don't know for what, but I mean, yeah, we can. That can be done offline. Does cache data come under ILF? Now, when you say cache data, it is either getting stored somewhere permanently, which is in ILF. It's just something you're holding in memory. Like for example, your session data. It is not an ILF. Does SP estimation include effort for documentation and testing also, or the coding effort? So again, it's not about testing, coding, etc. It's about sizing software. And but when you do that, there are templates that you will see when you have once you apply. So I'll say this, once you calculate function points, and then over a period of time you start gathering this data, where you say, my testing effort is this much per function point, my development effort is this much per function point, my even documentation effort is this much per function point. So that is how you are going to generate your organization wide data. So function point does not talk about whether it's testing, whether it's coding, or whether it's documentation. It's a tool to calculate functional user requirement size. Okay, the next question is, for a beginner, what would be the source of information or reference to apply function point analysis? The best reference, as I mentioned, is Accounting Practice Manual from IFPUG site. You can log in there, you can be a member, and then there is a facility from where you can download Accounting Practice Manual. There is a lot of other documentation which is available also on the internet, but this is more authentic and exhaustive documentation that I would suggest that you refer to. for Salesforce and SAP, they are more like technologies. Someone is asking about FTR is file type reference. I mentioned that in my presentation, which is ILS or EIS. Okay, someone is saying thanks for a nice presentation. Thank you, I appreciate.